Hello everyone. So today we are going to discuss on linear inequations, and in two variables, right? So let's discuss on that. That is the topic on which we are going to spend our time on that. So here you see that we have got some terms over here. So the moment I talk about linear, right? So what does the linear mean is that then I'm talking about the degree of the expression, right? Degree of the algebraic expression, right? Okay, so I hope you know that what is algebraic expression and what are degree. So here the degree is 1, right? So whenever we talk about the linear, so here it is going to be algebraic expression, right? Algebraic expression with degree of 1, right? And there are two variables, right? So two variables, that is the second important thing which you have to note over here. So there are two variables, and we know that the types of variables we have, is we have one is, you can say, dependent, and the other one is independent, right? So we have the two types of variable. One is the dependent and the other one is independent, right? And the independent variable, it is independent to take the values, and the dependent variable, it takes the value from outcome of what independent variable has taken, right? Okay, so there are two variables, we call them mostly as x and y. Okay, and then there is a word which we say as inequation, right? So we are going to discuss on inequations, right? So that what it is. So inequations basically, it involves that the term or the expressions like this and this, and strictly less than or strictly greater than. This we call as inequalities, right? Inequalities, right? These are inequalities, and these are strict inequalities. Okay, they are okay, and these are inequalities or inequations where, because the value of the expression can become equal to 0 over here. Okay, so let's move further, let's move forward and let's see that. Now you might have seen the expression like this: ax plus by is equal to c. Okay, so whenever this comes, so this is for equality, right? Okay, equality, and by this time you know that this particular expression, now the degree here, now degree is how much? The highest power of the variable, that is, it is 1, right? So that is, this is linear, right? Okay, and there are two variables, x and y, two variables, right? There are two variables over here, right? So there are two variables. Okay, now since there are two variable x and y and the degree is 1, so this we can say that they are linear equation. These are linear equations. These are linear equation in two variables, right? In two variables. So these are equations, right? So that thing has to be seen. Okay, now this is very important when we are discussing about this particular topic, because the primary solution which we will be deriving is the solutions of equations, and then we are going to modify it. Okay, so for example, let's take a universal example and then we will work it out around it. So let me call a simple example like 2x plus 3y, that is equal to 6, right? Okay, so you see that this is nothing but, if you have plotted this particular you can say expression, this is nothing but it is a line, right? Okay, so the graph, how the graph is going to look like, the graph is going to look like this. So I have got two coordinates, y and x. Now this side x is greater than 0, this side. Okay, and here on the upside y is greater than 0. So in the first quadrant, what we see that x is also positive and y is also positive. So if any plot or any point you are going to plot it, say x comma y over here, so you see that this is also positive and this is also positive. Now if you try to plot x comma y over here, now you see that x is decreasing on this side, it is less than 0 on this side, right? So you see that this particular, here it is negative and here it is positive over here. So y coordinate is positive in the second. I call this as my first quadrant. Okay, let me call this first and let me call this my second. So in the second quadrant, what happens is that x is negative and y is positive. Now let me call this my as third quadrant. In third quadrant, x comma y. Let's try to see the sign of each. So you see that this is x is negative over this side and y is also negative. So this is also negative and this is also negative. Now then I have got my fourth quadrant, right? In my fourth quadrant, what it is there is that if I put x comma y, so you see that x is positive, so this is positive, and y it is negative over here, so this is negative. Okay, so like this the coordinates are going to be there in the rectangular coordinate system, or you can say our Cartesian coordinate system. Now let's try to look at this particular line which we are going to plot over here. So for this, if I draw another set of my coordinate plane over here, so this is y and this is x. Now if I have to plot, right, if I have to plot this particular line, I have got simple trick, right? And what is that trick, or what is that method? I will put once x is equal to 0, I will try to find out what is the value of y. If I put x is equal to 0, you see 2 into 0, that is 0, and this is 3y is equal to 6, so y will be 2 over here. Now in the second thing, what I am going to do, I am going to put y is equal to 0. And if I put y is equal to 0, I get x is equal to 3, right? So you see that I got 2 points, 0 comma 2 and 3 comma 0. So let me plot these 2 points. So let this point be 3 comma 0. Okay, and this point will be it is 0 comma 2, right? So this point will be relatively closer here. There is 0 comma 2 over here, right? Okay, so I got these 2 points. Now we know that this is a straight line. So to draw a straight line, what we need is that we need at most 2 points or 1 point and a slope, right? So now we got 2 points, right? So we can draw this straight line. So this straight line is going to be this way, right? Okay, so this straight line is going to be this. Okay, so this is, you can say, 2x plus 3y equal to 6, right? So this is linear equation in 2 variable. It is equation now. Okay, now here one important thing is that you take any point on this. You take any point on this. You take any point. Whatever point you take on this, okay, so that is going to satisfy, right? Okay, all these points, say all these points are going to satisfy this particular equation, right? So all these points are solutions, right? All these points on line, on this line are solutions, right? Solutions of this equation, right? All these points are the solutions of this equation, right? Okay, so any point on this, if you choose it and then if you plug it into it, it is going to satisfy this equation. So all these points are the solutions. So it has got infinite solution. Okay, so there are going to be infinite points, so there are infinite solutions over here. Okay, so let's move forward and let's try to build a particular, you can say, concept related with inequality or inequations with this one. Okay, now let's come to what we say as inequations, right? Inequations. So we have our example, and what is that? That is 2x plus 3y. Okay, now I am going to modify a little, right? I am going to call it less than 6, right? Okay, I want to find out the region, or you can say a space or a point which is going to satisfy this particular kind of inequation, right? So let's see. What I am going to do is that let me plot it. So better is that people, if we do graphically, it get more recorded in our mind, right? You get okay. So we know that this particular points where this was, you can say, 3 comma 0, and this point was 0 comma 2, right? And we were able to draw the line passing through this, right? Passing through this. Okay, so this is my x-axis and now this is my y-axis. Now you see that here I am talking about 2x plus 3y less than 6. So less than 6, so I have got a choice over it, like how to find out this particular region, right? One way directly is that I take a particular point over here, right, and here. So here if I want to pick up a point, let me call like x more here than 3, that is 4, and more than 2. So let me call this as 4 comma 4 for my simplicity. This is point, and here we have got origin, right? That is 0 comma 0 over here, right? So that is the origin over here. Now if you see that if I try to put these 2 points here, right, okay, so if I put this over here, you see what is going to be the value of the expression, right? So this will become you can say 2 into 0, okay, at O, right? I am computing the value of this inequation at this particular point. So 2 into 0 plus 3 into 0, right? So is this value coming less than 6? Yes, true, right? It's true. So this point belongs to our solution set, right? Okay, so it belongs to our solution set. Now if I try to put this one, right, at P, okay, at P, let me check this. So 2 into 4 plus 3 into 4, is it less than 6? It is false, right? No, right? No. So what happens is that this particular point, it lies in our solution space, right? Okay, and if in fact if you see any point on like on this side, okay, so all the point on this side, all the point on this side, they are, what I can say is 2x plus 3y less than 6, right? And since I'm talking about strictly less than 6, so this line will be we won't consider any point on this line for that. So no point of this line is going to belong to our solution set, right? Okay, so there is no point of this line, okay, belongs to our solution set, right? Okay, so this means that all the points which are not part of this and which lies on, you can say, this side of this particular plane, they are our solution set. Okay, so this is our solution set, right? Our answer will slightly differ if the question would have been like, for example, if I have to find the solution set for 2x plus 3y less than or equal to 6, right? How my answer will differ is, let's try to see here. Okay, if I have drawn this line and this line is 2x plus 3y, okay, equal to 6, right? So here you see that all these points are also going to be the solution, right? They are going to now included on this solution set, and here graphically we are going to represent it like this, right? So for this 2x less than or equal to 6, that is our solution set for this, right? Okay, because the point on this line are also the part of our solutions now, right? Okay, so this is how we plot or we graphically try to find out whether which side a particular point lies or which is our solution space. Let's move further and let's try to discuss on greater than, right? So 2x plus 3y greater than 6, right? If the question goes like this, and similarly if I say what is the difference between 2x plus 3y greater than or equal to 6, right? So again, if I look from the solution point of view, here, since we have already found out the solutions for this, say this is my x and this is my y, and this is my x and this is my y, and then I have drawn up a line. So this point was, you can say, 3 comma 0, and this point is 0 comma 2 over here, and the same line let me draw over here. So this point is 3 comma 0 and this point is 0 comma 2. It is like this, and I know now my equation of this line, it is this is, now this space was less than, right? So now if I take the opposite space, like for example this one, this one, this one, so this is, you can say, 2x plus 3y greater than 6. Okay, and no point of this on this line is a solution space, right? So these points are not, so any point on this line is not our solution, right? So okay, but if you take any point on this side, they belong to our solution set. Okay, they belong to our solution set, right? That way it is. Now if it is for equal to, then what I am going to say, these points, right, it includes the points on the line also. Okay, so that will include the points on the line also, right? Okay, so this is 2x plus 3y greater than or equal to 6, right? So all the points on the lines are also included over here, right? So like that we plot the linear inequations in two variables, and then we try to simultaneously work on the problems where the common solution space is there, or where there are solutions associated with more than one condition, right? Let's try to do the problems on that. Okay, so let's see. So here is the first question which I have got. The first question which I have here is that the first question is, I have to find the area associated with the following set of inequations, right? So let me draw my this particular you can say um, problem. uh, it is like this. This is my x and this is my y, and then I have one line which is over here, and then there is another line, and then I have got the line which is like this, right? So I hope my line will be straight. Okay, and then what is given to me is over here is the points, right? So what are those points? Let's see. That is a, c, b, and this is 4 comma 0, 0 comma 3, right? So this is 0 comma 3, and this is 4 comma 0, and this is a, and this is c, and that is b, right? C and d. Okay, and now he is talking about the this region, right? Okay, so this region, and then he is asking us to define this region, right? Basically, so how to define? Now if you see that this particular line, right? So this particular line, it is given as x is equal to 4. This is x is equal to 4, and what is this? This is y is equal to 3, right? So if you take any point on this, that will be y is equal to 3, and if you take any point on this, that is x is equal to 4. Now how to write the equation for this AB line, right? So for equation of AB, if I have to write, then I have got simple and straightforward technique. And what is that? That is x by A intercept plus y by B intercept, that is equal to 1. So that means that it is x by A intercept is 4 plus y by 3, that is equal to 1, right? So that is nothing but 3x plus 4y, right? That is equal to 12, right? So this line, it is represented as 3x plus 4y equal to 12, right? That's what it is. And what is this point? This point, what we can say, this point is nothing, it is going to be 4 and 3, right? 4 comma 3, right? So you see that we are considering the space which is behind x is equal to 4, and which is beneath y is equal to 3, and which is above this line, right? So this we can say that this shaded area, okay, so the shaded area will be given by, okay, will be given by, you can say 3x plus 4y. Now if you choose any point, this point is, if you try to plug in, it is this particular expression value will be more than 12. It is greater than or equal to 12, equality for the points on this line, right? Okay, and then it is x is equal to 4. So these points are before x is equal to 4, right? So I can say x less than or equal to 4, right? So what I am going to say, that this side it is x less than or equal to 4, right? That plane it is. Now this side, what it is, y less than or equal to 3, right? And this side it is, you can say this side it is going to be what, 3x plus 4y greater than or equal to 12, right? So these are the boundary lines, or these are the lines which are defining this particular shape, right? And then it is, we have got y is less than or equal to 3, right? So this is bounded surface, so it is a closed surface, right? Okay, so this is how we can define a, you can say, a area in terms of inequations, right? Okay, so let's move and we try to do another question on okay, so I have got another question. Let's try to see what is the next question which I have got. Okay, so he is asking about the truth set of the following shaded region, right? Okay, let's see that. So the truth set. So second question I have got, question number 2, the truth set. And truth set, and what is you can say the graph. So I have got a line over there. This is what is my line, and this line I have got points, right? So that points are, these points are 0 comma 3 and 2 comma 0, right? So 0 comma 3 and 2 comma 0, right? Okay, so that what it is. And now he's talking about this particular area, right? I have to define this area, what it is, okay, in terms of inequality or inequations, right? Okay, so how to define that? So let me mark this point, like for example, this is origin, and this, let me call this A, and let me call this as B, right? Okay, so this area, okay, or this plane, right? So this particular zone, again, if you know, I can define this particular straight line, right? So this particular straight line is what it is going to be. It is simply x by 2 plus y by 3, as I have seen in the previous problem, that is equal to 1. Okay, and this area is, you can say, it is above that. So this, whatever the value of this expression is going to come, that is going to be more than 1, right? So this will become greater than or equal to 1, right? So that will be the answer. So you can say that this is 3x plus 2y, it is greater than or equal to 6, right? So that what it is. So here the truth set is, the truth set for this particular problem, it is going to be 3x plus 2y greater than or equal to 6. Okay, so that what it is. So that is how. So the truth set is nothing but that is the solution space which he is talking about. Okay, so that is another term which is given over here. The another, you can say, the word which is associated with the solution set. Okay, let's move and let's try to do the question number 3. Okay, so let's see what the question number 3 I have. Okay, I have to find now the solution set of. Okay, so now here we are going to discuss one important problem that is based on the modulus. Okay, find the solution of mod of 2x minus 5. Okay, so that is less than 4x plus 9, right? Okay, so this particular problem is associated with modulus. So you know that how a modulus function is defined. A modulus function is defined like this. It is x minus x if x is greater than or equal to 0, right? If the value is positive and 0 or positive, so what happens is that I am going to consider that particular value. If the value is negative, or the value of, you can say, the you can say independent variable is negative, then I am going to multiply with one negative sign. So x is less than 0. So the function definition is that if x is less than 0, it becomes minus of x, right? So that way. So it is like this. So okay, so this is defined as, you can say, modulus of x, right? So this function is mod of x. Now you know, okay, so that's how it is. And if I have got if you can say if some condition is given, like for example, mod of x is less than a. Now the solution for such problem is what? It is that x is going to lie between minus a to a, right? So x will be between this. If it is equal to, it is equal to, or else it is less than, strictly less than, right? So here we have got strictly less than condition. So let's try to evaluate the solution for this kind of problem, right? Let's see. So on looking from here, okay, I am going to borrow the solution for this particular problem, right? So for then what can I say is that I can say that 2x minus 5, the value of this expression, it is going to lie between 4x plus 9 or minus of 4x plus 9, right? That what it is. Now from this I will get one solution, and from this I will get another solution. So this is, I will call it as 1, and this is 2. If I try to solve my like first set of equation, so what I am going to get, let's see, I will say minus 4x plus 9, right, is less than 2x minus 5, right? Okay, so if I multiply with minus 1 both the side, inequality get reversed, right? Remember that. So 4x plus 9, this will be greater than minus 2x plus 5, right? That what it is. Okay, multiply minus 1, right? Both sides. Okay, so that what it is. So I have multiplied with minus 1 both the side, it will become this. Now I will add 2x both the side, right? If I add both the side 2x, it will become 6x. Okay, plus 9, that is greater than 5, right? So I will now subtract minus 9 both the sides. So it will become 6x is greater than minus 4. So what this gives is that x is greater than minus 2 by 3, right? So this is, you can say, first set of solutions from first set of equation which I am getting. Now from the second set of equations, let's try to do it. Now from here, what can I say is that 2x minus 5 is less than 4x plus 9, right? That what it is. So I will add minus 4x both the side. So it will become minus 2x. Okay, and I will add plus 5. So okay, so minus 4x plus 5 I am doing, right? So this is minus 2x, minus 5 plus 5 will be gone. Okay, so plus, that is 13, right? Now what can I say? Then I divide both the sides with minus 2, right? So the inequality get again reversed. So x is greater than, you can say, minus 13 by 2, right? Okay, so here I am getting the set of solutions that x is greater than minus 13 by 2, right? So if I take my number line, okay, on this number line, if I take a point, say O, right? Uh, Let me put this point over here, and then let me put say this point, right? So that is minus 13 by 2, that is going to be over here, and minus 2 by 3. So minus 2 by 3 will be over here, right? From first set of equation, right, what is it is giving me these solutions, right? Okay, from 1, what I am getting is this, right? And from 2 I am getting this, right? All the solutions which are over here. Okay, this is from 2, right? So from 2 I am getting this. Now here you see that our solution has to be complying both the conditions. So the space which is complying both the condition is what? This is this space, so this is solution space. So this is our solution set. Okay, so this is our solution set. Okay, so that is going to be the answer for this particular these kind of problem, right? So like that you are going to solve, right? So here basically the student know, they should know like how to what is the definition of a mod function. Now a modulus function has come, right? So you should be good at that, understanding what it is. And then the value of mod function lies between you can say you can say the values in which it is defined, right? Between which it has been defined. And then you have to find the solution, right? Here what is the mistake which the people will be doing is that they will be missing what is the solution set. So the solution set has to be the common of the solutions which we are getting, right? Okay, so the common here is going to be you can say the solution which is coming from first set of equation, right? So like that you have to judge you can say that what is the answer for this kind of problems. Okay, let's move. We try to do another question, and this is question number 4. Okay, what does this particular question says is that find the area of a quadrilateral formed by the solution set of inequations, right? So he is talking about area of the figure, right? So now, and what are the conditions given? The conditions given are 2x plus 3y, 2x plus 3y is less than or equal to 12. That is one condition given. And then x is greater than, you can say x is greater than 0, and y is greater than 0, and x is less than 3. So x is less than or equal to 3, x is greater than or equal to 0, and y is greater than or equal to 0, right? So this what it is, these are the conditions which are given to us. Okay, we have to find the area of the figure which is bounded by all this, or which is closed by this, right? For open, okay, so it might happen that in some of the cases that the figure might be coming as an open. In that case we cannot find the area or if the boundary is it is open, then in that case we won't be able to find the perimeter, right? So this thing has to be remembered. So let's try to do it graphically. Okay, so let me call my this as let me call this as my y-axis, and then I have got my x-axis. So this is x and this is my y. Okay, then okay, so first is that if I want to plot x is less than or equal to 3, right? So for that I will straight away take this point. Okay, so this is, you can say this point is over here, right? X is equal to 3. Now if I draw this line over here, okay, so let me call this point over here like this, and if I try to, so this is x is equal to 3, x is less than equal to 3 will be this space, right? This side, x is less than or equal to 3, right? So this side it will be. Now x is greater than 0, so x is you can say here, this side what it is, so this side is x greater than or equal to 0 it is, right? Okay, y greater than or equal to 0, so that side it is going to be, you can say y greater than or equal to 0, right, on upside. Okay, so this side and this side, so somewhere area is between here and on the, you can say, upside, so it is in the first quadrant he is talking about. Now I have got this line also, right? So if I have to plot this line, I know that how to do it. So 2x plus 3y, right, is less than or equal to 12, right? So what I'm going to do is that I'm going to first choose the line which is of equality, right? So 2x plus 3y equal to 12. So to find this point, what I can say, I will put x is equal to 0, I will get y. So y will be 4. If I put y is equal to 0, so what I am going to get, x is equal to 6. Okay, so I got now the 2 points, right? So these points are what? This is 0 comma 4, and this point is what? This is 6 comma 0. Okay, so let me mark this point. So this point will let be over here, 6 comma 0. Okay, and 0 comma 4, so 0 here and 0 comma 4, let me call this as over here, 0 comma 4. Okay, and now let me connect them, right? So if I connect them, right, so if I connect them, so this space, right, so this line is 2x plus 3y is equal to 12, right? So the space down this, okay, so that is 2x plus 3y less than 12 it is, right, on this side. Okay, so here this area, and you can say the area between these two and upside area, right? So what is the area of interest? The area of interest is this particular area, right? So let me mark now this point, let me call this as A, this is obviously O, and let me be B, let this be C, and let this be D, right? Okay, so he is asking about this particular area. So what is this shaded area it is going to be? Now you see that this is a perpendicular line and this is a perpendicular line, so there is 90-degree angle over here. Okay, and here is also 90-degree angle, so this is basically a trapezium. So figure ABCO is trapezium. Okay, it is a trapezium, right? So this is a trapezium. Now okay, so can we define the coordinates of B, right? Yes, we can define the coordinates of B. What is this going to be? So it is 3, right, and this is x coordinate of on this line also, right? So I will put it over here. So this is 6, so 3y is equal to 6, so that y is 2, so this point is going to be 3 comma 2. Okay, so I can find out now this. Now if you have to find out the area of this, you can say area of ABCO, that is nothing but area of trapezium, right? So what is that? That is half multiplied with the distance between the parallel sides. Okay, so what is this distance? This is 3, and what is this? This is 4, and this is here, what is this height? 2, right? So that is going to be half multiplied with 3 multiplied with 4 plus 2, right? So this will be 6, so 6 into 3, that is 18, and that is 9 square unit, right? So 9 square unit is the area of this particular, you can say, figure. Or else, what else you can do is that you can work it on the areas of the triangle, right? So you see that the area of triangle AOD, how much it is? It is half multiplied by 6 into 4. So that is 12, right? And what is the area of triangle? You can say BCD, right? So what is this? Half into it is 2, and then it is multiplied with 3, right? So this is 3, right? So area, this shaded area, it is going to be what? The shaded area is going to be, you can say, area of ABCO, right? So what is that? That is going to be 12 minus 3. That is the area of triangle AOD, the bigger triangle area minus the smaller triangle area, right? So that is 9 square unit. Okay, so like that we can find out the areas, right? This is 9 square unit, right? So this is all how we can use the inequations and how the problem associated with the different forms of inequations which we come across in exams and how we can tackle them, right? So that's what it is. Thank you all, and thank you for your patience to view this